Assalamualaikum warahmatullahi wabarakatuh. My name is SALIZA FARHANA binti MOHAMAD SAZIRU with matric number 2110-21160, and I'm here to present our mini project titled Image Segmentation and Object Counting. This project is a collaborative effort by our team, which includes SYAHIRAH binti SABRI, SITI SYAZWA binti SHUIB, and myself. The primary objective of this project is to create a system that can effectively segment images and count objects within them. This topic is highly relevant and image processing due to its applications in areas such as medical imaging, traffic monitoring, agriculture, and industrial automation. By addressing this topic, we aim to contribute towards improving the efficiency and accuracy of visual data analysis. The problem we aim to solve is the difficulty of accurately segmenting images and counting objects, particularly in challenging scenarios such as complex backgrounds or overlapping objects. To address this, we have outlined key objectives, which are designing a system that performs precise image segmentation, enabling accurate object counting, and validating our results using benchmark dataset to ensure reliability. With that, I'll now pass it over to SYAHIRAH binti SABRI, who will explain the technical details and implementation of our project. Thank you.
Hi, Assalamualaikum. My name is SYAHIRAH binti SABRI. My matrix number is 2110-21162. Now I'm gonna continue with project methodology. Our main goal was to detect and count objects using image segmentation. To do this, we follow a systematic approach. First, we use the traditional technique such as the thresholding to simplify the image and contour detection to detect the object boundaries. Then we also applied the watershed algorithm to handle the overlap object. Next, the object was implemented using the Python, the language that we use, leveraging libraries, and also OpenVC for image processing and skitlearn for advanced segmentation. This tool help us process the image, extract features, and also segment of the project accuracy. Next, this slide provide the end overview for the step we followed. First, we loaded the image and converted into the SYAZWA color model to isolate the color information. Next, we applied the thresholding to create a binary image and blur the reduced noise. Contours we detected and refined to focus only significant object. To separate overlapping the object, we use the watershed algorithm, which divides connected object into distinct regions. Despite some challenge, this workflow enabled to achieve accurate result. Next, we move to implementation visual. Here's the visual presentation of our workflow. On the left, we have the original image. In the middle, you can see the binary thresholded image, contour detection, highlight object boundaries, while the results show how overlap the object were separate using the watershed algorithm. This step ensures accuracy to detection and counting. Next, for the key features, one of the standout features of our project is how traditional method were combining to achieve the accurate result. Thresholding separate the foreground from the background, blur, reduce noise, and also the watershed algorithm helped a lot handle the overlapping objects. Next, for the challenge and solution, any object we face challenge, for instance, noise in the image cause false detection and also overlapping the object were hard to spread. To overcome this, we apply blurring to reduce noise and also the distance transform with the watershed algorithm for better segmentation. We also find the fine-tune the parameter like threshold to ensure the reliable result. Next, for the conclusion, in the conclusion, we successfully segmented the counted apples and the image using traditional techniques, which is the method work well for the structured environment with well-defined object. However, they also struggled with complex backgrounds and also the subtles of object features. For the features work, we recommend to exploring deep learning based on the method like MAS RCNN or YOLO for the reboost and adapted solution. Thank you.
I will explain the result. First, we need to import the library such as NumPy, CV2. Next, we will move to the read and image. The image is loaded using the OpenCV CV2 inbuilt functions and is displayed to the verify its content and dimensions using the method. For the next step, which is a convert to HSV. The image convert to the HSV color model to separate color information hue from the intensity value and aids in segmentation based on the color properties. This helps in separating color information to better segmentation. Next step is thresholding. Its use also method is used to automatically determine an optimal threshold value for creating a binary which is a black and white image. This highlights the areas of interest, example an apple, against the backgrounds. This convert an image to a binary image which is they have a 2 pixels only, which is a 0 or 255. Step 3, which is a medium blurring. Blurring the image to remove unnecessary spot in the image or reducing a noise and a small artifact while preserving object edge. Step 4 is a contour detection. Draw the contour. Contours are detected from the blurred binary image using CV2 fine contour. This contour represents the boundaries of the detected objects. Next, which is a filtering contour by the area. Contour with the area larger than curtain threshold 2000 pixels are selected to eliminate noise and irrelevant object. Step 5 is a refined contour based on error, which is we draw a refined contour line in the red and the number of apples found after refinement is a 10. 6, which is a watershed segmentation. I will explain one by one. First is a distance transform. A distance transform is a compute from the binary image to measure the distance of each pixel from the nearest background pixel. This step to find the center of the object. Another one, which is a detect local maxima in the distance transform, which is the peak in the distance transform are detected as a potential object a center. Another one, which is apply the watershed algorithm for the segmentation, which is this method segment overlapping or connected object into the distinct region. Last but not least, which is a combined result to estimate the total number of a segment apples. The results from the contour detection and the watershed segmentation are combined to estimate the total number of detected apple. The total number of detected apple, which is 8.